So I have two more synthesis examples I want to show you. The only way to learn how to do these syntheses is to just practice them. And you kind of get used to the sequences after a while. Okay, so here we've got a 4-carbon compound, and our final compound, our product, is 6 carbons. So we're going to need to add 2 carbons. So the best way to do that is going to be to get our sodium nitride out, and that'll be our first reaction. That will remove this hydrogen. Then our second reactant is going to be to add ethyl iodide. And that will add an ethyl group right here. Let me make that new ethyl group a new color. We'll make it a green ethyl group. Okay, so now we've got the right number of carbons, but we need to add these bromine in here. So we're going to want to reduce this triple bond, and we're going to want to make our double bond a trans bond so that it will look like this. So it's beginning to resemble our final product. Then we can add bromine to it to get our final product. Note that the product here is meso, and so only one product is made. So let's look at F. F is very similar, except the configuration is different. We're going to want when we have our double bond at this second step, we're going to want it to be cis, so that we'll get this structure right here. But again, we have a 4-carbon compound, and our product is a 6-carbon compound. So we will use the sodium nitride to remove that proton, and then we'll add, let's change our color, ethyl iodide, and that will give us a compound that looks like this. Let me change back to black, do our triple bond. We'll reduce the double bond, but this time, instead of using the sodium in ammonia like we did last time, we're going to use Lindar's catalyst. And some hydrogen, of course, and we'll come up with something that looks like this. Then when we add our bromine to it, we'll get the structure above. Of course, when we add bromine, it'll add anti. One of the bromines will be up and the other bromine will be down. And the two compounds that are made will not be identical. They'll be mirror images of each other. The other one will look, the enantiomer will be the mirror image. And if you try and put those on top of each other, they are not the same. Okay, so there ends the chapter.